Good morning all of you. Welcome back to my YouTube channel Ruby Management Academy. Hope you all are doing well. Today I come up with one more new concept, that is probability distribution types. Before we move ahead, a gentle reminder for you, those who are not subscribed yet, kindly do like, share and subscribe the channel. Those who are not seen the previous videos, kindly go through the previous videos, because those are all important concepts which I am coming with. Without any late, let's get started. In this video I am going to be discuss the what is probability distribution, what are the types of probability distribution. Here we are going to be discuss total 15 types of probability distribution. Total 15 types of probability distribution. Don't miss the class. Ask all of your friends to join the class and make a note of it. Whatever the important points I am telling in this video, kindly make the notes of it. It will be helpful at the time of examination. It may have the quick revision. Chalo, without any late, let's get started. Before going to have a discussion about the probability distribution, let me know the idea about the statistics. What does it mean? Where it will be helpful? Here, statistics is an important role in determining the existing position of a per capita income, unemployment, population growth rate, housing, schooling map, medical facilities, and lot more in a country. Now, statistics hold a central position in almost in every field of like industries, commerce, trade, physics, chemistry, economics, biology, psychology, botany, astronomy, IT, and a lot more. As we know, statistics means it is a branch of science. It will helpful to collecting, analyzing, organizing and interpreting numerical facts, which we can easily call it as data. Here statistics has been classified into two types. What are they, guys? This concept as we already have in the net paper 1. What are they? How many types of statistics are there? One is descriptive statistics and the one is inferential statistics. What does it mean? Descriptive statistics, as the name suggests, data speaks for itself. Data speaking itself, describing. What about the inferential statistics? It will be helpful to interpreting the results. It will helpful to draw the conclusion about the population. Helpful to draw the conclusion from the population. A basic tool in the study of inferential statistics is probability. What are the examples of descriptive statistics and inferential statistics? What are the examples of that? As I told you, descriptive statistics specified the values. It is talking about the values. Whereas inferential statistics, for example, what are they? For example, when you roll a die, the possible outcomes are 1, 2, 3, 4, 5 or 6. Up to 6 we can expect under descriptive statistics, because it is talking about the specified values. It is talking about specified values, whereas inferential statistics, it will helpful to draw the conclusion from the population. In these inferential statistics, we can expect the decimal values. Decimal values means the range may be finite or infinite. What would be the example for these inferential statistics? We can take the goal, height, weight, length of the road. Those are all we can take the example of inferential statistics, because we can expect the decimal values. The goal height may be 5.4 to 4.5, means here infinite number we are expecting under inferential statistics. It is not fixed, not be fixed, whereas in descriptive statistics it is fixed values, specified values we are considering. As I told you the example of when you roll a die, we can expect the possible outcomes. What are up to 6 we can expect, either it may be 1, 2, 3, 4, 5, 6. This is the difference between descriptive statistics and inferential statistics. As I told you, the basic tool in the study of inferential statistics is probability. Let us have a discussion about the probability distribution. What does it mean? Probability distribution gives the possibility of each outcome of a random experiment. Each outcome from a random experiment. Again, we can take the example of dice. Again, we can take the example of dice. When you roll a die, we can expect the possible outcomes up to 6. Either it may be 1, 2, 3, 4, 5 or 6. Or else we can take the other example also, heads and tails. When you toss a coin 3 times, when you toss a coin 3 times, the possible outcomes may be 0 heads or 1 head or 2 heads or 3 heads. We can expect these possible outcomes. The probability distribution is completely talking about the possible outcomes from a random experiment. Possible outcomes. Here we need to be remember this point, possibility, as the name suggesting possible outcomes. It gives the possibility of each outcomes, possibility of each outcome from the random experiments. Let me have the what are the characteristics of probability distribution. Here we are having 3 major conditions of probability distribution. What are they? The probabilities for random events must lie between 0 and 1. The possible outcomes it must be lie between 0 and 1. The sum of all probabilities of outcome should be equal to whatever the sum we are going to be have, that should be equal to 1. The outcomes are mutually exclusive events. These are the major conditions or the characteristics of probability distribution. Let me have the types of probability distribution. Before we jump into the types of probability distribution, let me have what are the types of this probability distribution. Here it has been classified into 2 types. Those are discrete distribution, discrete probability distribution, and continuous probability distribution. What is discrete distribution? Discrete, as the name suggests, we can take only specified values. For example, as I told you in the inferential and continuous, inferential and descriptive. Here also we can take the same example under descriptive, under discrete probability distribution. it can take only specified values. It can take specified values. What would be the example for this discrete probability distribution? When you roll a die, the possible outcomes 1, 2, 3, 4, 5 or the 6, and not 1.6 or 2.45 like that. We may not be expect the values or in decimal points. The specified we can expect the only specified values. What about the continuous probability distribution? It can take any value within the given range. The range may be finite or infinite. We can have the finite values and infinite values. As I told you, the example of girl's height, weight. The weight of a girl can be any value from 54 kgs or 54.5 kgs or 54.46 kgs. Here the example indicating the continuous probability distribution, because here under continuous probability distribution, the values within a given range, it may be finite or infinite. We can expect the specified values as well as decimal continuous values. This is the difference between discrete and continuous value, continuous probability distribution. What are the types of this discrete probability distribution? In the beginning itself, I told you in this video we are going to be discuss total 15 types of probability distributions. What are they? Bernoulli distribution, binomial distribution, geometric distribution, hypergeometric distribution, multinomial distribution, negative binomial distribution, Poisson distribution. Under continuous, it has been segregated uniform distribution, normal distribution, gamma distribution, exponential distribution, chi-square, logistic distribution, Weibull distribution, as well as T distribution. These are all the types of probability distribution. Before we jump into the explanation of these distribution types, let me have the common difference between the discrete and continuous distributions. What are the common differences we have? Under discrete distribution, we are having finite number. As I told you, we can expect the finite numbers, whereas in continuous, we can expect finite as well as infinite. Both we can expect under continuous. As I give the example also. Weight of the girl, it would be 55 kgs, it would be 55.4 kgs, it would be 55.653 kgs. Like that we can expect finite. This number indicates the finite, this number infinite. Under continuous, we can expect both finite and infinite values. What would be the other difference? We can add up individual values to find out the probability of an interval. We can't add up the individual values under continuous distribution. Discrete distribution can be expressed with a graph, piecewise functions or the table. Whereas continuous distribution, it can be expressed with a continuous function of or the graph. Under discrete distribution, the graph consists of bars lined up one after the other. The bars lined up one after the other, whereas in continuous, we can expect the continuous graph like this. See the diagram. Under discrete, we can expect the bars one after the other like this, whereas in continuous distribution, we can expect the continuous graph, because This can have the finite and infinite values. It considers the finite as well as infinite. With these values we can have only the continuous graph. Under discrete distribution, expected values might not be achievable, whereas in continuous distribution, to calculate the chance of an interval we require integrals. Let us have the discussion of types of distribution one by one. The first one is Bernoulli's distribution. Bernoulli's distribution. In Bernoulli's distribution, there is only one trial and only two possible outcomes. Make the notes of this important point. Under Bernoulli distribution, it is talking about only one trial. Only one trial and two possible outcomes. Two possible outcomes. It is denoted by P. What are the characteristics of Bernoulli's distribution? It consists of single trial, only one trial, it having the two possible outcomes. What would be the formula of this Bernoulli's distribution? F of x is equal to p power x into 1 minus p whole power 1 minus x. What would be the example for this Bernoulli's distribution? As we can take guessing a single question, true or false, dichotomous questions like yes or no, true or false, success or failure, loss or gain. These are the examples of Bernoulli's distribution. Whether it is going to rain tomorrow or not, where rain denotes success and no rain denotes failure. With this diagram also we can identify which type of distribution we are going to be applied. We are talking about only one trial with the two possible outcomes, either success or failure. Here the probability of success P is not same as the probability of failure. As you can see in this diagram, this success is not similar to this failure. Remember this point, probability of success under Bernoulli distribution, probability of success is not same as probability of failure. What is, let us go to the next one. Binomial distribution. What is the difference between Bernoulli's and binomial? Under Bernoulli we can have only one trial with the two possible outcomes, whereas in binomial let us see, binomial distribution is applied in binary outcome events where the possibility of success is equal to probability of failure. What I told you in the Bernoulli's distribution, probability of success is not be same as probability of failure, whereas in binomial distribution probability of success is same as probability of failure. A sequence of identical Bernoulli events is called binomial distribution. Here it can be denoted with n comma p. N and p. What are the characteristics of binomial distribution? Over the n trials, it measures the frequency of occurrence of one of the possible results. For multiple trials, each trial is independent to each other. The results of one trial can't influence the other trial. Each of the trial can have two possible outcomes, either success or failure. Here there is no limit for the trials. We can have number of trials, but the possible outcomes are two possible outcomes only, either success or failure, either P or 1 minus P. What would be the formula for this binomial distribution? N factorial by x factorial into n minus x factorial into p power x into 1 minus p whole power n minus x. This is the formula of binomial distribution. What we can discuss the example for this binomial distribution. Let us take the example of coin. How many times we obtain a head if we flip a coin 10 times? If you flip a coin 10 times, how many times we can expect the heads? How many times we can expect the heads? Other example also we can take lottery tickets. When you buy 10 tickets of same kind, it is mostly used when we try to predict how likelihood an event occurs over a series of trials. Suppose that you want to win the toss today, and this indicates a successful event. You toss again, but you lost this time. If you win a toss today, this does not necessitate that you will win the toss tomorrow. Do you understand what I am saying? Suppose that you want to win the toss today and you flip the coin. This indicates a successful event. You toss again, but you lost this time. If you win a toss today, this does not necessitate or that you can win the toss tomorrow. It doesn't indicate like this, no. It can be any number depending on the number of times you tossed a coin. It is depending on the number of times. It is depending on the number of times you tossed. Number of times you tossed. Number of times you tossed. This is the example of binomial distribution. What is the difference between this binomial and distribution? Binomials and binomial distribution. Under binomial distribution, the possibility of success may not be same as probability of failure. Whereas binomial distribution, probability of success is the same as probability of failure. It is simply depending on number of trials you have. But we are having only two possible outcomes. Having two possible outcomes, with number of tries. What is the next one? Geometric distribution. Under geometric distribution, number of trials need to get the first success is repeated independent Bernoulli's trials. In other words, the geometric distribution can also be defined as a number of failures before the first success happened, or the vice versa. This geometric distribution talking about the number of failures before the first success happened. Number of failures before the first success happened. The geometric distribution is an appropriate model of the following assumptions. What are they? The phenomena being modeled is a sequence of independent trials. It is a being of independent trials. There are only two possible outcomes for each trial. As we are discussing from the Bernoulli's distribution. Under binomial also having the two possible outcomes. Under geometric also having two possible outcomes. Often designated success or failure. Either success or failure. What would be the formula for this geometric distribution? P of 1 minus p whole power n minus 1. What would be the mean for this? 1 by p. Variance 1 minus p by p square. Here P indicates the probability of success, N indicates the number of first successful trials. For example, in financial industries, geometric distribution is used to do a cost benefit analysis. It will helpful to find out the cost benefit analysis. Cost benefit analysis to estimate the financial benefits of the certain decision making. It will helpful to identify the financial benefits through cost benefit analysis. Other example also we can take for the geometric distribution, that is, if you suppose a dice is repeatedly rolled until 3 is obtained. Suppose if you roll the die until 3 is obtained, then the probability of getting 3 is 1 by 6, and the random variable x can take on a value of 1, 2, 3 until the first success is obtained. This is an example of probability of this is an example of geometric distribution. What is the next one? Hypergeometric distribution. Hypergeometric distribution, it is closely related to the binomial distribution, but it is not the binomial distribution. It would resembles like a binomial distribution. The trials are not independent. Whereas in geometric, trials are independent. Under hypergeometric trials are not independent. In geometric, trials are independent. And the hypergeometric trials are not independent. The probability of success changes from trial to trial. The success may changes from trial to trial. The hypergeometric distribution describes the number of successes in a sequence of n trials from a finite population without any replacement. What would be the formula for this hypergeometric distribution? P of x is equal to S of Cs into n minus S C of n minus S by n C to the n, whereas S indicates success from population, capital S indicates success from population, small s indicates success from sample. Here small s indicating success from samples, capital S indicating population, capital N indicating population size. N is sample size. Here one of the most common application of the hypergeometric distribution is in industrial quality control, such as calculating probabilities for defective parts produced in a factory. It will helpful, this hypergeometric distribution will be helpful to identifying the defective parts produced in the factory. Let's say a factory line produce 1% defective parts that are boxed at the end of the line. The hypergeometric distribution can be used to model the occurrence of defective parts for quality control purpose, as long as the items being sampled from a box are not replaced, and this will not be replaced, as I discussed in the definition, without any replacement. And another more example, a small voting district, 101 females. Let us take 101 female voters and 95 male voters. A random sample of 10 voters is drawn. Sample. Out of these female and males, 10 voters is drawn. What is the probability? Exactly 7 of the voters will be female. Will be female. 101, we need to put these values into that formula. 101 C2 7 into 95 C3 by 196 C2 power 10. If we solve this value, we can get the exact figure. We can find out the 7 of the voters who are the females out of these 10 random voters. Let us discuss next one, multinomial distribution. This multinomial distribution used to measure the outcomes of experiments that have 2 or more variables. As the name suggests, multi, more than one, 2 or more. 2 or more variables. It is the special type of binomial distribution where there are 2 possible outcomes such as true or false. Under binomial, we can expect only 2. Bi in the sense 2. Under multinomial, 2 or more. 2 or more. The distribution is commonly used in biological, geological, financial application. It will be helpful in different kinds of industries. The following are the properties of multinomial distribution. What would be the properties of multinomial distribution? An experiment can have a repeated number of trials. For example, rolling a die multiple times. Repeated number of trials we can expect when we toss a coin or when we roll a die. Number of repeated trials we can expect. Here what we can remember? Number of repeated trials. Repeated trials we can expect. Repeated trials. Each trial is independent of each other. Under binomial, it will not be independent. The success probability of each outcome must be same. Means constant for all trials. What is the formula for this multinomial distribution? It resembles like a binomial distribution, but it is not a binomial. P is equal to n factorial by n1 factorial, n2 factorial, so on up to n power x. N indicates number of experiments. P indicates probability of occurrence of an experiment. A binomial experiment can have 2 outcomes only, either success or failure, either true or false, either loss or gain, while a multinomial experiment can have multiple outcomes. Number of trials, repeated trials we can expect. When you roll a die 10 times to see what number you roll, there are 6 possible outcomes. What are they? 1, 2, 3, 4, 6. It may be 1, it may be 2, it may be 3 or up to 6 we can expect when you roll a die. 6 possible outcomes we can expect. 6 up to 6 we can expect. So this is a multinomial experiment. If you roll a die 10 times to see how many times you roll a 3, that would be binomial experiment. Have you understood the difference between these two? Under binomial distribution, when you roll the die 10 times, if you roll the die to see how many times you roll 3, how many times you roll 3, that would be talking about binomial distribution. Whereas multinomial distribution, when you roll a die 10 times to see what number you roll, that is talking about multinomial. It may be 1, it may be 2, it may be 3 or up to 6 possible outcomes are there. Number of tries you can expect the number when you roll a die. Here this is the difference between multinomial and binomial distribution. Have you understood, guys? If you haven't understood, make a leave a comment in the comment box. As early as possible I will give the reply. Let us go to the next one, negative binomial distribution. Negative binomial distribution. The negative binomial distribution is known as Pascal distribution. We can also, what is the other name for this negative binomial distribution? Pascal distribution. We can also call it as Pascal distribution. A discrete probability distribution of a number of tries in a sequence of independent and identically distributed Bernoulli tries before a specified or fixed number of successes occur. Sometimes the negative binomial distributions has also defined as a probability distribution of number of successes needed to get a fixed number of values. This negative binomial distribution experiment almost the same as binomial experiment with one difference. What is that? A binomial experiment having the fixed number of tries. The binomial having the fixed number of tries. What about this negative binomial distribution? No fixed. There is no fixed number of tries. What is the example of this negative binomial? What is the formula for this negative binomial distribution? n minus 1 to the k minus 1 p power k into 1 minus p of p power n minus k. Here n indicating the number of trials, n indicating trials, p indicating the probability of success, k indicating the number of success. Here you can see the diagram of negative binomial distribution, how it would be when you apply to find out the number of success. There is no fixed number of tries, and this is a main characteristics of this negative binomial distribution, don't have the fixed number of tries. Take the example of deck of cards. When you shuffle them and choose a card, replace the card and repeat until you have drawn 2 aces. Shuffle them and replace the cards and repeat until you have drawn 2 aces. We want to take 2 aces. You need to shuffle them or replacing the cards, but you have to draw the 2 aces. Y is the number of draws needed to draw 2 aces, as the number of trials is not fixed. That is, if you stop when you draw the second ace, this makes it a negative binomial distribution. What it indicates? When you stop when you draw the second ace. As you draw the second ace, you stop it. This make it a negative binomial distribution. Does not have any fixed number of trials. But what is the task for you? You have to draw 2 aces from the deck of cards. But having number of tries until you get 2 aces. That is negative binomial distribution. What is the other name for this negative binomial distribution? Pascal distribution. And the next one is Poisson distribution. These are all the types of discrete or continuous. Discrete distribution, discrete probability distribution comes under discrete probability distribution. Here the Poisson distribution is used for finding the probability of a number of events in a time period, or finding the probability of waiting some time until the next event comes. Waiting some time until the next event comes. It will helpful to find out the time, finding the time until the next event comes. That shows how many times an event is likely to occur. It shows how many times an event is likely to occur within a fixed intervals of time or space. This Poisson distribution helps to find out the waiting time and or space if these events occurs with a known average rate and independently of the time since the last event. This Poisson distribution is associated with the both time and space. Here the time would be independent of each other. Time and event are independent to each other, and space or time and event both are independent to each other. This is the key point we need to be remember. This Poisson distribution will helpful to finding the waiting some time until the next event comes. Here this time and event both are independent to each other. What are the conditions or the assumptions of Poisson distribution? The success probability for the short span is equal to success probability for a long period of time. The success probability in a duration equal to 0 as the duration becomes smaller. A successful event can't impact the result of another successful event. Here, this successful event may not be impact. This successful event may not be impact on the another success. Here, following are the characteristics. Following are the characteristics. What are they? The events are independent of each other. As I told you, the time and the space are the independent to each other. This is one of the characteristics. It does not affect the probability of another event. As I discussed on the assumptions, one result may not be impact on the another successful factor. An event could occur any number of times in a defined period of time. What is the next one? Any two events can't be occurring at the same time. The two events may not be occurring the same time. Number of events occur, the two events may not be occurring the same time. In the same time, two events may not be occur. This is the main important point. Another important point is the average rate of events to take place is constant. The events to take place is the constant. The average should be the constant. What is the formula for this Poisson distribution? Note the points of these assumptions and characteristics of Poisson distribution. From these we can expect the question also. Note down these assumptions and characteristics. What are there? The events are independent to each other. The time and the events are independent to each other, and the events of two events may not be occurring the same time, and the average of the events take place is constant, and the success probability for the short span is equal to success probability of long period time. Short span is equal to short span of time is equal to long period of time. What would be the formula for this Poisson distribution? V of x is equal to lambda power x into e power minus lambda by x factorial. Here lambda represents the possible number of events take place in the fixed period of time, whereas x indicates the events in the time period. Lambda indicating the possible number of events, x indicating the number of events in the time period. What would be the example we can discuss under Poisson distribution? Let us take the example of telecalling. Customers calling a health center. On average, there are say 10 customers. On average, there are 10 customers which call in an hour. Thus, Poisson distribution can be used to model the probability of a different number of customers calling within an hour. Say 5 hours, 6 hours, 7 hours, or 8 hours, 9 hours, or 11. The diagram below represents, here this diagram representing the number of visitors. On an average 10. This Poisson distribution will be helpful to finding out the different number of customers calling within an hour. Within an hour, how many customers has called to this customer care. With the help of this Poisson distribution, we can identify. And the next one is uniform distribution. And the next one is uniform distribution. As of now we have discussed the discrete distributions. Discrete probability distributions up to Poisson distribution. What we have discussed till now: binomial, Bernoulli, geometric, hypergeometric, multinomial, negative binomial, and Poisson distribution. Now we are going to jump into the continuous probability distribution. That is, the first one is uniform distribution. It comes under continuous probability distribution. We can also call it as this uniform distribution. We can call it as rectangular distribution. As you can observe in this diagram, here rectangular. This is the reason the other name for this uniform distribution is rectangular distribution. The uniform distribution is a type of continuous probability distribution that has the constant probabilities. Simply speaking, that it is a type of probability distribution in which all outcomes are equal to chance of occurring. All outcomes should be equal. All outcomes are equal. Here you can see for A and B the outcome should be same. This is the reason we call it as a rectangular distribution. What are the characteristics of this uniform distribution? In uniform distribution, all outcomes are equally. In graph, all bars are equally tall. Its expected values and variance have no predictive power. Guys, what would be the difference between statistics and probability? Can you please give me the answer in the comment box? What would be the answer? What is the difference between probability and statistics? Probability, okay, I will tell you. Probability will be helpful to predicting the future events, whereas statistics will be helpful to analyzing the past events. Probability helpful to predicting future or past future events. This will helpful to predicting the future events, whereas statistics predicting past events. Analyzing past events. This would be the difference between statistics and probability. Let us come to the uniform distribution. It is talking about the all outcomes are equal. The key point you need to be remember is All outcomes are equal. Outcomes are equal. Here are the characteristics. What are the conditions? The area under the curve must be equal to 1. The area of curve, it should be equal to 1. The length of the interval determines the height of the curve, that is 1 by b minus a. And a and b are the parameters. Here we have taken two parameters a and b to find out the height of the curve, that is 1 by b minus a. If you randomly approach a person and try to guess his or her birthday, for this uniform distribution we can take the example. Interesting example I will tell you. If you randomly approach a person, and try to guess his or her birthday, the probability of his or her birthday falling exactly on the date you have guessed follows a uniform distribution. This is because every day of the year has equal chance of being his or her birthday, or every day of the year is equally likely to his or her birthday, right? For example, probability that the 1st January is suppose 1st January is his or her birthday is equal to 1 by 365 days, which is the same as the probability that the 2nd January is his or her birthday, which is the same as the probability of each and every day of the year to be his or her birthday. This we can take the example for this uniform distribution. Interesting example. Remember, this uniform distribution helps to identify the predictive power, where all the outcomes are equal, chance of occurring. As I told you the example of birthday, the January 1st is supposed to my birthday is equal to 1 by 365 days, because which is the same as the probability that the 2nd January of his or her birthday, which is same as the probability of each year, every day of the year to be his or her birthday. The next one is normal distribution. What is the normal distribution? What is the other name for this normal distribution? Gaussian distribution. We can also call it as Gaussian distribution. It is a type of symmetric distribution. Symmetric in the sense like this. Symmetric distribution where most of the observations cluster around the central peak, and the probabilities for values further away from the mean topper of equal in both directions. It depends upon the two factors, mean and standard deviation. This normal distribution depends on two factors. What are they? Mean and standard deviation. Mean mu and standard deviation sigma. Mean determines the location of center of the graph. This mean indicating the, here if you can observe this diagram, mean indicating the center of the graph, whereas standard deviation determines the height of the graph. Here, how far this graph going, height. This sigma indicating the height of the graph. What are the characteristics of this normal distribution? Mean, median, mode or coincide. Mean, median and mode or coincide. Located at the center of the distribution. It is located in the center of the distribution. The distribution curve is the bell-shaped curve. It is bell-shaped curve. The distribution curve is symmetrical along x is equal to mu. Mu indicating the location of the center of the graph. Center of the graph. The area under the curve is 1. Approximately 68.2%. 68.2% of the data falls within the 1. whereas 95.4% of data falls within second standard deviation. Second standard deviation, first standard deviation 68.2, second standard deviation 95.4, 99.6 data falls in third distribution, third standard deviation of the mean. What is the formula for this normal distribution? Z is equal to y minus mu by sigma standard deviation. Here what we can need, mean we need to find out, standard deviation have to find out. The y value will be given in the problem. Let us take the example of pizza delivery, McDonald's pizza. Let us look at the pizza delivery. Assume that a pizza restaurant has mean delivery time of 30 minutes. Delivery of 30 minutes and the standard deviation of 5 minutes. Using the empirical rule, we can determine that 68% of the delivery time are between 25 to 35 minutes. %95 are between 20 to 40 minutes. And 99% it should be between 15 to 45 minutes. For analyzing these results, we can apply this normal distribution. Put the values in this formula, we can get the appropriate results. This normal distribution, talking about the two factors, those are mean and standard deviation, where this mean, median, mode are the coincide with each other. It should be located in the center of the distribution. This is a bell-shaped curve. It is a symmetrical distribution. It is a form of symmetrical distribution. What is the other name for this normal distribution? Gaussian distribution. In the examination, they may confuse not to ask the other name, that is Gaussian distribution. Remember this other name also. The next one is gamma distribution. Gamma distribution is a continuous probability distribution. That is widely used in different fields of science to model continuous variables that are always positive and have squared distribution. Those are always, you can observe this diagram, it is always positive and have the squared. Positive, it is always positive. The exponential distribution, log distribution, chi-square distribution are the special cases of gamma distribution. It occurs naturally in the process where the waiting time between events are the relevant with the two positive parameters. So those are alpha and beta for shape and scale. Here under gamma distribution we are taking the shape and scale. Applied to gamma function, the mean of gamma distribution is, what would be the mean for this gamma distribution? Alpha into beta, and the variance is alpha into beta square. E is the what is the formula for this gamma distribution? E power minus x power p minus 1 by gamma p. Here E indicates the natural number, so we have to take the value from the gamma distribution table. If you go through the gamma distribution table, we can have this fixed number of E value. K is indicating the number of occurrence of an event. If k is a positive integer, then gamma k is equal to k minus 1 factorial is the gamma function. We can take the example of rainfall. The amount of rainfall accumulated in a reservoir. With the help of this gamma distribution, we can find out the amount of the rainfall accumulated in the reservoir. And also we can take the size of loan defaults or size of the loan defaults the insurance claim, the flow items through manufacturing and distribution process. These are all the examples of which we can apply the gamma distribution. This gamma distribution is a part of continuous probability distribution. This is talking about the positively skewed. Remember of this diagram. With this diagram we can identify what are the characteristics we are having. This is positively skewed. Positively skewed. If this diagram indicating the left side, that is negatively skewed, negative gamma distribution. But here we are talking about the positive gamma distribution. In this gamma distribution we are taking only two positive parameters, those are alpha and beta. The next one is exponential distribution. Exponential distribution is widely used for survival analysis, as we know, from the expected life of machines to the expected life of human. This exponential distribution will helpful to identify or expecting the life of a machine. It will helpful to identify the life of a machine, how long it will be working. What are the characteristics of this exponential distribution? Probability and cumulative distributed functions plateau after a certain point. After certain point it will be cumulative. We don't have a table to know the values like the normal or chi-square distribution. Therefore we mostly use the natural logarithm to change the values of exponential distribution. As I discussed in the previous distributions, we can expect the table values. In the previous gamma distribution, E value they has given, where we can find out under the table of gamma distribution table we can have the values, table values. Whereas in exponential distribution we not have the table values, specific table values. What is the formula for this exponential distribution? Lambda into e power minus lambda x. Here mean is 1 by lambda, variance is 1 by lambda square. What would be the example? We can take the example of call center. How much time will go before a customer call happens? How much time will go before the next customer arrive in the shop? How much time will pass by before the next robbery happen in any part of the city? How much time will pass by before the next childbirth in the city? How much time will go until the customer finish browsing and actually purchase something in your store? How much time will go until the bus arrives? This exponential distribution identify or expecting the life or time. How much time it will take, how much time it will take, or it will go until the bus arrives. How much time it will pass before the next childbirth? How much time it will take before the next robbery happen in the city? How much time it will go before the next customer arrive into the shop? All these questions it will be through exponential distribution we can find out the answers. It will helpful to expecting the life of a machine, life of a particular factor, how much time it has taken. With the help of this exponential distribution we can identify the successful results. Here certain point the probability and the cumulative distributive functions will be plateau. And the next one is chi-square distribution. Famous test chi-square distribution. In the previous exams also some of the questions has asked from this concept, that is chi-square distribution. This chi-square distribution is frequently being used. It is mostly used to test goodness of fit. It will be mostly used to finding the goodness of fit. This goodness of fit talking about tells about how closely distribution of the categorical variable matches an expected distribution. This chi-square distribution talking about the expected values and observed values. Expected and observed. With the help of these expected and observed values, we can find out the successive results. The denoting this chi-square distribution denoted with the symbol of chi-square. It is a special case of the gamma distribution and is one of the most widely used probability distribution in inferential statistics. Notably in hypothesis testing and in construction of confidence intervals, this chi-square distribution will be used. Mostly it will be helpful to finding the goodness of fit. What does this goodness of fit, what it talks about? It tells about how closely this distribution, how closely this distribution of the categorical variable matches an expected distribution. It's completely depending on the expected and observed results. Whether the variables is likely to come from the specified distribution or not. In simple words, we can say that this chi-square distribution will helpful to identifying whether the variable is likely comes from specified distribution or not. It also checks whether two categorical variables are independent of each other or not. It helpful whether the variable comes under. Note down the points, guys. This chi-square distribution helps to finding whether the variables comes from specified distribution or not, whether these two categorical variables are independent to each other or not, whether they are dependent or the independent, we need to find out. It is based on the frequencies and independent of parameters like mean and standard deviation. These are the important key points of this chi-square distribution. What are the characteristics of this chi-square distribution? The graph obtained from chi-square distribution is asymmetric. It is not a symmetric. The symmetric distribution should be like this. Central point will be there. It is bell shape. It is in the form of bell shape. It is symmetrical. But in chi-square distribution, it is asymmetrical. It is not in bell shaped curve. Asymmetrical distribution and skewed to the right skewed. If you can observe this graph, the curves are rightly skewed. What is the formula for this chi-square distribution? Chi-square is equal to summation of observed values minus expected values whole square by expected values. For example, if you gather data about the gender of students enrolled in science, arts and educational program, we have taken three categories like science, art and education programs. You have to find out we have three categories. What are they? One for each program. The degree of freedom is 2 or the 3. In this graph, each curve represents the chi-square distribution for a different degree of freedom. Each curve, you can see the diagram here. Each curve representing chi-square distribution for a different degree of freedom. Here one curve representing Here yellow curve representing the degree of freedom of 1, green curve representing the degree of freedom is 2. Like this, each curve representing the different degree of freedom. If the chi-square value is 5 for a set of data that has a degree of freedom equal to 4. This will helpful to finding the gender of students enrolled. How many students are enrolled in specific categories? What are the categories we have taken? Science, art and other programs. The simple key points what you have to remember, guys, in this chi-square distribution, this will helpful to find out whether the variables likely to comes from the specified distribution or not, whether the two categories, two variables are independent to each other or not. This will helpful to find out. It's simply talking about the goodness of fit. You need to remember this point, goodness of fit. It tells about the closely distribution of the categorical variables. How closely distribution of the categorical variable. How closely related to the categorical variable, which matches an expected distribution. It depends on the expected values and observed values. And the next one is logistic distribution. How many are there? Viable and student. 2 more are there. Within a 5 minutes we are going to be wind up the session. Don't worry, guys. I know this video is going to be lengthy, but don't worry. It is most important concept, guys. This is the reason I am taking marathon class. Be patient until the class will be going to end. 2 more concepts are there. 2 more types of distributions are there. I am going to end up this session as early as possible. Be patient. Logistic distribution. Comes to logistic distribution. It is used to observe how continuous variable inputs can affect the probability of a binary result. It is denoted with the symbol of mu and s. It resembles like the normal distribution because it is having the bell-shaped curve. It resembles but not the normal distribution, because as the heavier tiles here, and if you can observe this diagram, heavier tiles resembles the normal distribution. It is used for growth model and is used in certain types of regression moves as the logistic regression. What are the characteristics of this logistic regression? Logistic distribution, cumulative distribution function picks up when we reach values near the mean. When we reach to the mean value, the cumulative distribution, this distribution going to be peak levels, peaks. The lesser the scale parameter, the faster it reaches the value close to the 1. What is the formula for this logistic distribution? It resembles, it looks like a normal distribution. It may have the characteristics are the same, but not the same. It resembles. What is the formula for this logistic distribution? 1 by 1 plus e power minus x minus mu by s. Here mu indicating the location parameter. Here mu indicating the location. Location parameter, whereas sigma indicating the scale parameter. If we discuss the example, you can easily remember this logistic distribution. Let us take the example of credit card. A credit card company want to know whether transaction amount and credit score impact the probability of a given transaction being fraudulent. To understand the relationship between these two predictor variables and the probability of a transaction being fraudulent, the company can perform this logistic distribution. Have you understood the example? Listen carefully. A credit card company wants to know whether the transaction amount and credit score, transaction amount and credit score impact the probability of given transaction being fraudulent. To understand the relationship between these two variables, two predictors, we can use this logistic distribution. There are some who argue that logistic distribution is inappropriate for modeling lifetime data because the left hand limit of the distribution extends to negative infinity. Because this left hand limit we are talking about, this left hand limit leads to the negative infinity, negative distribution. That is the reason there is a argue with this logistic distribution, because it is some are saying that this is inappropriate for modeling the lifetime data. Because this, if you can see this graph, it is somewhat going to be left side skewed. It means it indicates the negatively infinity. This could conceivably result in modeling negative times to failure. However, provided that the distribution in question has the relatively high mean and relatively small location parameters, the issue of negative failures time should not present itself as a problem. I think so. Let us go to the next one, viable distribution. Let us go to the viable distribution. It is a continuous type of probability distribution. The viable distribution has the ability to assume the characteristics of many different types of distribution. It is helpful to assume the characteristics of many different types of distributions. It is flexible enough to model a variety of data sets because it is rightly skewed as well as left skewed and symmetrical data. We can expect right skewed, whereas in logistic we can expect the left skewed, whereas in chi-square right skewed, rightly skewed, whereas in viable right skewed is there, rightly skewed is there, left skewed is there, symmetrical also there. See the peak of the distribution, normal distribution. Generally speaking, the viable distribution is determined by three parameters. So what are they? Shape, scale and the location. The location of the parameters is to be 0. It should be set as a 0. The only reason to use this viable distribution is because of its flexibility. It is flexible to assume the characteristics of many different types of distribution. Assume the characteristics of many different types of distribution. The location parameter, we can see the three parameters in this viable distribution. What are they? One is shape, scale and the location. But the location of these parameter will be set as a 0. Compared to other type of distribution, this viable distribution is the flexible one, because as you see in this diagram, we are having these data sets. It should be right skewed and left skewed, and also it be symmetrical data set, because it can simulate various distributions like normal and exponential. We can see this in the diagram. It indicates the normal distribution as well as exponential distributions. What is the formula for this viable distribution? Beta by theta power beta into x power beta minus 1 into e power minus x by theta whole power beta. Here alpha Alpha is the shape parameter, whereas beta is the scale parameter. Here beta is the shape parameter. Beta is the shape parameter. Beta indicating the shape, how it is, whether it is leftly skewed or rightly skewed, or whether it be symmetrical. This beta indicates the shape parameter. Shape parameter, and the theta is a scale parameters. Theta indicating the scale. Mu the location parameter. Mu is the location. Beta is equal to 1. The Bible reduce the exponential distribution. The location should be 0. Location should be 0. Here mu should be 0. And theta indicating the scale parameter, whereas beta shape parameter. Bible distribution, where it will be helpful. Reliability engineering, lifetime, failure analysis, electrical engineering, we can use this Bible distribution. In electrical engineering, to represent over voltage occurring in a electrical system, we can use there this Bible distribution will be applicable. This application will be helpful to finding the over voltage occurring in the electrical system. In survival analysis also we can use in weather forecasting, and the wind power industry, to describe wind speed distributions, as the natural distribution often matches the Bible distribution shape. In general insurance, to model the size of reinsurance claims, or maximum rainfalls, river discharges. In all the places this Bible distribution will be applicable. However, unlike the normal distribution, it can also model skewed data. In fact, extreme flexibility allows it to model both left, right and skewed data. This is the flexibility we are having in this Bible distribution compared to other distributions. This is the flexible one, where the data extremely flexible to left skewed, right skewed and symmetrical. This is all about Bible distribution. And the next one is, final one is student t-test. Student t-test, we can also call it as a t-test, t-distribution. Student t-distribution, or simply called t-distribution, is used to estimate the population limitation when the sample size is small and population variance is not known. By the time this student t-distribution will be helpful to identifying the or to estimating the population limitation. Population, when the sample size, by the time the sample size should be small and the population variance should not be known. Population variance not known. These are the conditions. The sample size should be same and the population variance not be known by the time this student t-distribution will be applicable. What is the symbol to indicate this student t-distribution is T. T. What are the characteristics of this student t-distribution? A small size estimation of normal distribution. As I told you, what is the conditions? Small size should be how, and the population variance should not be known. By the time only this t-distribution will be applicable. This is one of the characteristics of this t-distribution. The graph of symmetric and bell-shaped curve. The graph is, if you can see this diagram, the graph is in bell-shaped curve, bell-shaped and symmetrical. It is in symmetrical. However, it has large tails. It is symmetrical about 0, bell-shaped, but more spread out than the normal distribution. It is widely used for hypothesis testing. It is widely used for hypothesis testing, to build confidence intervals from the mean values. It will helpful to testing the hypothesis. Note down this point, testing hypothesis. It will helpful to testing the hypothesis. What is the formula for this student T distribution? T distribution T n minus 1 is equal to x bar minus mu naught by standard deviation s by root n, where degree of freedom n minus 1. What are the conditions for this student T distribution? The sample must be randomly selected and continuous. It is randomly selected and should be continuous. Use when the sample size is small. Use the population variance or standard deviation not be known. The observation should be independent of one another. The data should not contain outliers. Outliers should not be there. Sample size should be small. Is the sample size greater than 30? Sample size greater than 30, then we can have the student T distribution. This will helpful to measure the average test score from a sample of only these are the main characteristics of student T distribution. What are the points we need to be remember under student T distribution? This is when the sample size is small, when the population variance and the standard deviation are not known. By that time we need to be applicable, as well as we need to be observed that should be independent of each other. The observations should be independent to each other. Independent to each other. Before going to wind up, let me tell you the difference between let us have a glance once what we have discussed in this video. We have discussed what is probability, what are the types of probabilities. Total 15 types of probabilities we have discussed. We have discussed the discrete distribution, continuous distribution. What is the difference between both? The main difference we need to remember between normal distribution and logistic distribution lies in the tiles and the behavior of a failure rate function. Number of trials. The logistic distribution slightly longer tails compared to normal distribution. Having number of tiles, infinity number of tiles compared to normal distribution. Also in the upper tail of the logistic distribution. Binomial distribution having the fixed number of trials. As we already discussed before, binomial having the fixed numbers compared to the logistic. There is no fixed number of trials. Whereas Poisson, compared to Poisson distribution also, no limit of the possible outcomes. Having two possible outcomes under binomial distribution, the bi itself indicating 2, whereas multinomial itself indicating more than 2. Under Poisson also there is no limit for the possible outcomes. Geometric distribution having the fixed number of successes factors. We already discussed the example also for this. Hope you all of you understood about these 15 types of distribution, probability distributions. Still, if you have any doubt, leave a comment in the comment box. As early as possible I will get back to you guys. If you want the PDF of this video, I will give the link in the description box. There you can download it. If you want to attempt the quizzes regarding paper 1 and paper 2 as well as for current affairs, you can join my Telegram channel, official Telegram channel. In the description I have given the link. You can join directly. and daily you can attend the quizzes also for your preparation. Chalo, that's all for today, guys. Hope you all enjoyed this session. If you enjoyed this session, kindly do like, share and subscribe the channel. I will come up with one more new concept. Until then, bye bye. Stay safe as the corona cases are going to be increased day by day. Kindly stay safe and wear the mask. Until then, bye bye.